Good morning, and thank you for joining us today. I am Tom Stroup, President of the Satellite Industry Association, and I want to welcome you to our May webinar titled Commercial Remote Sensing Satellites Enable Climate Action. This is the first in SIA's new monthly webinar series addressing timely topics for the satellite industry. Before we jump into our program, I'd like to cover a few housekeeping items. We request that all attendees turn off the camera on your computer or device. Additionally, your microphones are muted, so please use the chat feature in Teams if you have a question for our panelists. For those of you who are joining an SIA event for the first time, here's a brief background on our organization. SIA was formed in 1995 with the primary mission to promote the U.S. commercial satellite industry. We represent satellite operators, manufacturers, launch companies, and ground equipment providers. Through a variety of fora like this, we provide information on our industry to our members, government officials, and members of the public. We also serve as an advocate on policy issues and encourage any of you who are not members of SIA to consider joining us. Our website is www.sia.org, where you can find membership information, past copies of the SIA monthly newsletter, industry data, and bios for each of today's speakers. We have an amazing group of panelists joining us today, but first let me introduce our moderator, Jen Hindin with the Wiley law firm. Jen is a partner in Wiley's Telecom, Media, and Technology practice and chair of the Space and Satellite Group. This is her 25th year practicing space law. Jen advises communications and technology companies on regulatory, policy, and transactional matters, as well as FCC licensing and regulation of space stations and Earth stations. Jen, good morning, and over to you to introduce our panelists and lead our discussion today.
Thank you, Tom. It's a pleasure to be with you all today with this exciting topic where, as Tom mentioned, we're going to be talking about commercial remote sensing satellite systems and how they provide the data that empowers governments, companies, and individuals to address the challenges facing us today for climate change. I appreciate that Tom gave a little bit of my bio. We've got three great speakers. We have 45 minutes and a lot to talk about. So I thought what we would do first is that I would just briefly let each of the speakers give some introductory remarks about themselves and their company. And then I'll run through some questions so we can start our discussion. And of course, throughout, if you have questions, please put them into the chat and we'll try to get to them as well when we hear what's on your mind as well. So the first speaker today is Conor Brown. Conor is the Director of Sales Engineering for Federal Government Users at Spire. Conor?
Hi, Jen. Thanks so much. So as Jen mentioned, my name is Conor Brown, and I'm the Director of Sales Engineering here with Spire's Federal Group. I want to thank SIA for inviting me to participate in today's webinar, and for those that have called in to listen and engage and discuss with us about this essential topic. At Spire, we operate a constellation of over 110 nanosatellites that are performing a wide range of radio frequency remote sensing techniques. This includes tracking of ships using AIS signals, tracking of aircrafts using ADS-B signals collected from our satellites, as well as a suite of Earth intelligence remote sensing techniques using global navigation satellite systems signals of opportunity, such as radio occultation and reflectometry, to improve our weather prediction capabilities. At Spire, we believe it's absolutely essential to play a critical role in humanity's efforts to study climate change indicators and its impacts, which could help drive support and mitigation efforts. Every day, we strive to enhance the data we collect and improve our tools to help tame the unpredictability of weather through advanced atmospheric and remote sensing techniques. My particular role on the team is to work with our U.S. federal customer base to understand the challenges our government is facing and to help convey solutions using Spire's growing portfolio of maritime, aviation, weather, and Earth intelligence data sets. I look forward to engaging with you all today and to discuss further the role of Spire and commercial remote sensing satellite capabilities as a whole in enabling climate action. Thanks, Jen. Back to you.
Thank you, Conor. Now I'd like to introduce Mark Mazzina. Mark is the Senior Director of Government Affairs at Planet, and now you'll get to hear from Mark.
Good morning. Thanks. It's wonderful to be here today, and this is a very timely topic. So I'm very excited to dive in with my fellow panelists. So let me start by saying I'm Mark Mozina. I head up our government affairs here in DC, so all of our engagement with the Hill and agency leadership and the administration. And we are ecstatic for the new signals coming out of Congress and coming out of this administration to prioritize addressing the climate challenge. And we're a company that is built on this idea of providing data to individuals, communities, companies, and government agencies to help them make better data-driven decisions. So not just data for climate science, but also data for action. And so Planet is a company started about 10 years ago. We're a child of NASA Ames. Our founders came out of NASA Ames. Today we operate the world's largest constellation of remote sensing satellites and the second largest constellation of satellites in general. They're a combination of medium and high resolution CubeSats, the majority of which are about this big, but we also have some higher resolution satellites that are about the size of your dishwasher. The satellite constellations image the entire planet every single day. So the entire world's landmass, we have a new image of it every day. And so this provides an enormous amount of data to our customers, about 25 terabytes a day, in which they can see the evolving planet. So we don't sell our satellites, we sell our data. Like Spire, and we have a variety of customers, the majority of which on the commercial side, about 70% of which are commercial customers, led by agriculture and disaster relief, insurance companies, infrastructure, energy companies, city planning, enforcement, et cetera, and about 30% on the government side. I'll leave it there, but I'm excited to dive in and answer some questions from our audience.
That's terrific. Thank you, Mark. And now let me introduce our third speaker, Karen Jones. She is Senior Project Leader at the Center for Space Policy and Strategy with the Aerospace Corporation. Karen?
Thank you, Jennifer. I'm excited to be here as well. It is absolutely a very timely topic. And working for the Aerospace Corporation's Center for Space Policy and Strategy, we're closely following all these trends, particularly in the commercial world. They have a huge role to play with climate change and environmental accountability. The Center for Space Policy and Strategy has written a few papers. Our latest will come out next month on environmental accountability, transforming satellite data into action. And a slide here that I just quickly want to present, and I think we're going to discuss this at the end as well, is how this is all evolving. If you look at what's happening in the world, we have various levels here: data, connectivity, the cloud platform itself, and then AI and machine learning and predictive apps. All these are huge enabling layers that are making this revolution happen as far as our awareness of the climate. Starting with open data policies, currently only 7% of government data is fully open, and only half of data sets are machine readable. Now, this is changing. We're slowly building and creating increased open data. So that's going to help. The next layer, connectivity, IoT, Internet of Things, 5G, broadband satellites, proliferated LEOs. We're hyper connected at this point. That's absolutely an enabling factor. And above that is the cloud platform, which involves infrastructure as a service. The virtualization of the cloud and the analytics is enormous. And commercial players such as IBM, Amazon Web Services, Microsoft Azure are working closely with commercial satellite operators. It's also lowering the bar as far as who can play, because if you can virtualize what you're doing in the cloud, you don't have the enormous capital expenses. That's part of the revolution. And finally, as we all know, artificial intelligence plays a huge role in what Spire and Planet are doing as well. So we think all this is going to help, and it's going to connect us as communities on the local level, citizen science, the regional level, industry associations with regulatory focus, with state and local governments, as well as transboundary environmental geopolitics, multilateral agreements. Later, we're going to be talking about the Paris Agreement. So it can work across these different dimensions, and it's kind of the kind of supporting modern data architecture you need to be able to communicate across spatial lines as well as disciplinary lines as well. So excited to talk about that today.
Jen, I think you're muted.
Thank you, Mark. Despite best efforts in planning, it still happens. But I was thanking all the three of you for that wonderful foundation that you put together for the rest of our conversation here. And reminder that if anybody wants to ask a question, they should certainly use the chat function. But to kick it off, Conor and Mark, you each gave us a bit of an overview of your companies and the type of data that you collect. Could you go into a little bit more detail about that type of data, how often you collect it, and what are some of the use cases, specifically in the context of addressing the challenges of climate change for that data? And then Karen, maybe you could take a look at what they say and let us know how these various data sources can be used to complement and validate each other as well. Maybe Conor?
Yeah, absolutely. Thanks so much, Jen. So I'd like to focus a little bit more on the Earth intelligence data Spire collects. So as I mentioned in my introduction, we have over 110 CubeSats. These are 3U CubeSats similar to the size of the Planet Dove spacecraft. And so these have a variety of radio frequency remote sensing payloads. One of those payloads is an L-band receiver. And so this collects and receives frequencies from all of the global navigation satellite systems, such as GPS. And we do different things with those signals. So one of the primary measurements we do and the data we sell is radio occultation. So that actually takes the signal coming from a GPS satellite in medium Earth orbit. And as that signal goes through the Earth's atmosphere and bends or refracts, we measure that when it's received on our spacecraft. And because of the differential orbits, we're able to extract high resolution vertical atmospheric profiles and extract information such as temperature, pressure, and humidity. And then we take that information, and then we package that and use that for better weather prediction. So each day we're collecting over 10,000 radio occultation profiles, globally dispersed. If you actually lay these profiles out on a map, it covers the entire globe. And because of the orbital distribution of our spacecraft, being in a variety of different inclinations in low Earth orbit, we're able to do that really nice spatial resolution. And then we use that for a variety of different data processing techniques. We have our own in-house numerical weather prediction capability. So we run our own weather model 4 times a day and offer that as a service to customers, both at a global scale and for optimized point forecasts. And we also sell lower level data, and we've had good success collaborating with government agencies on that effort. So taking the actual lower level 1 data as opposed to a weather forecast, delivering the actual radio occultation profile for simulation into the NOAA's weather model, for example. In addition to that, we perform another sort of measurement with these GNSS signals, which is reflectometry, which is a form of bistatic radar. So instead of measuring the signal as it passes through the atmosphere, we measure it as it bounces off the surface of the Earth. And with that information, we're able to extract a lot of really compelling information that can help us measure changes within the Earth. So with that, we can get soil moisture measurements, or we can measure sea ice extent or sea ice characterization. Is it first year or multi-year ice in the Arctic? And also with that information collected from so many different satellites, we're able to track and map change. And with this data, there's a wide number of applications and use cases that we can talk about today. I'm sure some of those will come out in later discussions, but it's a few, just to name a few, we're really focusing on the Arctic region because it's one of the areas in our world that's changing the fastest. And because with our radio occultation satellites, which we have dozens in orbit, we're able to perform sea ice altimetry. And all those measurements, which I mentioned for reflectometry, Only a portion of those satellites have dedicated deployable antennas that are pointed towards the Earth, but a vast number of our satellites have the ability to perform what's called grazing angle altimetry. So that's a measurement at lower incident angles with the side-pointed radio occultation antennas. So we can actually really come up with compelling data to perform domain awareness and also measuring change in the Arctic region. With so many of our satellites in polar orbit, that's an emphasis for us. Other use cases like soil moisture and weather data for things like wildfire prevention and detection are an area we're looking at. We recently signed a commercial agreement with a company called Aurora Tech, who's going to launch a proprietary thermal infrared camera and data processing payload. I'm sure Planet has lots of applications they can apply to the wildfire prevention, detection, and monitoring use case as well. So those are just a couple, but maybe I'll yield my time to the speaker and we can get into some more later.
I can jump in. So Planet, as I mentioned earlier, we are a remote sensing constellation. So today we have about 200 satellites in space. Primarily they're about the same size as Spires, like Conor said, so 3U, so that big. And we very much took an approach of agile aerospace. So instead of the traditional design a satellite, build a satellite for 5 years, then operate it for 15 years, we went the other direction. We design our satellites, and we can build our satellites in-house very quickly using components that we can buy off the shelf so that we can keep our costs down. And so as a result, we're constantly iterating and constantly improving our capabilities, improving the number of bands we have, improving their sensitivity, improving the capability, the resolution, etc. So we're launching about a third of our fleet every year. So that means roughly every 3 years, our entire constellation is upgraded. And this is important because we design our constellation in tandem with public assets already in space. So Landsat and Sentinel. I mean, the legacy of Landsat is now almost 50 years old, and it's really an incredible legacy of providing this constant monitoring of our planet. And so Planet, as the name implies, is trying to build upon that legacy and supplement that data for not only for scientists but also for enabling action in communities and action with companies and individuals. So as a result of this constellation, we're bringing down 25 terabytes of data a day, and we use it for. We have partners and customers in a wide range of fields. I'll just kind of blaze through a few, and maybe there's some questions to dive in any of the specific examples. But as this data is coming down and is being used kind of across the different industries, so some that I'll highlight. Allen Coral Atlas is an example of a program that uses our data to track the coral reef health of all the coral reefs in the world. We have the California Forest Observatory, which is in tandem with the state of California, that uses our data to look for indicators and variables that might lead to forest fires. One of the most powerful aspects of our constellation is that we're not only taking the picture of where you know to look, we're also taking a picture of where you didn't know you wanted to look, because we're imaging the whole planet every day. And so whenever an event happens, a natural disaster happens, a flood happens, a dam breaks, an avalanche happens, other satellites didn't know to look there, but we naturally did. So we can rewind time, and you can watch what happened the day before, the week before, the month before, and you can build analytics to understand that. And so when those types of actions start to happen again, you can predict that potentially you could be going into a similar situation again. Our largest single user is on the agriculture side. So enabling smart agriculture, enabling more efficient watering and pesticide use and insurance use, et cetera. We've been very involved with a NASA program, a NASA commercial small sat data acquisition program, in which scientists use our data for a wide range of different applications. We're now up to the point where our data is being used for new publication every single day. Every 24 hours, there's a new publication using our data. We're very proud of that. NASA Harvest, we partner with them. They use our data to increase global food security for developing world. flood risk with cloud to street uses us. And the use cases just keep going on and on. I'll kind of stop here. We can dive in, but I'll end it with a very exciting program that we announced just a few months ago. It's with Norway. It's with their Ministry of Climate and Environment. It's the NICFI program, and what we're doing there is we're imaging the tropical forests of the entire world for them, so that they can track the health of those forests and help governments of those different countries meet their obligations and their commitments to protecting those forests. And so by having this daily monitoring of these forests, we can track the roads that go in for illegal logging before the illegal logging happens. And so we can alert those governments to go shut down that illegal logging before it actually happens. We can also track the health and the carbon stock in these forests, so we get an idea of how much carbon and the health of these forests is actually there. So I'll pause there. As you can see, I can probably go on for the entire 45 minutes, but that would not be useful.
Well, and in fact, we have our first question, which has already come in. I think it came in right when Conor was speaking, but it applies really to the comments from both of you. And I think it'll set the stage for Karen's further remarks. So the first question that came in, how critical is zero or low latency to gathering satellite climate data? And, when I think of latency, I usually think of literally the transmission time for the gathering of the data to get it back down to Earth. But low Earth orbit satellites, I know, at least from Planet's perspective, they're not fixed in a single position over the Earth. They're transferring. So maybe in addition to talking about the latency, you could talk about sort of the frequency of the data collection as well, and how important that is to climate solutions.
Sure. I could maybe start there. So when we think about latency, it often depends on the use case. So a lot of times for climate data collection, if this is data that's getting in the hands of researchers to study longer term change, latency may not be as critical. But for so many of our customers, latency is important. For our weather forecasting, it's not important that we get it down in seconds, but certainly within 90 minutes or less, we need that radio occultation profile to be assimilated so that it can make the next run of our weather forecast model, for example. For things like tracking of ships and planes, latency is very important because that translates directly to our API, which is going to show you the latest collection of that vessel, and that fuels our artificial intelligence and prediction algorithms to predict future positions. So having the latest and greatest in our cloud processing systems is certainly important for applications like that. But even planes move faster than ships. So you could argue latency is much more important for the aviation aircraft. But specifically to climate, I think it really depends on the application. As I said, the way that we reduce our latency is we operate a network of 29 ground stations distributed throughout the globe. That's been a network we've grown over the years and will continue to grow. And we're also investing in technologies like inter-satellite links and things like that to help smarter data routing on orbit to take advantage of those ground opportunities, because so much of the data we collect is over open ocean or in remote regions where it's not practical to bring the ground segment in. And I'm sure that, with imagery data, there's different considerations that Mark can speak to, but that's sort of how Spire looks at it.
Sure. In terms of for Planet, we have two different fleets, if you want to think about it, in constellations. The answers will be different. So for the medium resolution, which is this always on, always scanning, you don't task it, you don't point where it looks. It's just, think about it like it's a ring of satellites going roughly North Pole to South Pole, just sun synchronous technically, so that it's always the same time of day when you take the picture, so the shadows don't change. So it's easier to understand the change between days. So this ring of satellites going North Pole to South Pole is moving while the world is spinning under it. So it's constantly scanning, it's always on, always taking pictures. The latency there, it's that data will be, the images will be captured, stored, and then as we go over a ground station, we have roughly 50 ground stations around the world, we'll downlink the data, put it on the cloud, and then it'll be accessible to everyone with a license within the day. So that data, it's not instant. It gets scheduled. It has to do with capacity and such. But that's kind of an automatic system. The other side of our fleet are these high resolution satellites, and these are more traditional that you might think of from the movie. There's a building you care about, there's a farm you care about, there's a port you care about, there's something you care about. So you upload a coordinate, the satellite as it flies overhead, tasks, takes a picture of it, and then downlinks. And for those, similarly, they get uploaded onto the cloud, which means they're accessible anywhere in the world. And the latency there will depend on a variety of things, like the use case, the customer, whether it's an emergency or whether it's just a monthly picture we take of this facility for a customer, et cetera. An example in how we've turned around these images for natural disasters. We're able to reduce the time down to just hours. And so when, for example, when avalanches hit India earlier this year, scientists were given open access to our data to have immediate access to the medium resolution. And as the high resolution tasking satellites went overhead, that data was made available as well. So whenever there's a natural disaster that happens, if it's declared, there's a whole network that we've signed up to. So as this network declares a natural disaster, we open up our data so that people can use it. And there, the latency can really drop in terms of time. And we're moving towards, as a community in the future, maybe we'll get to this at the end, we're moving towards a point where we will be able to significantly drop that latency as we start to combine technologies from the constellations like ours that can image the whole planet with improved communications in space, such as with OneWeb or with Starlink from SpaceX or others. That'll allow customers to actually upload coordinates for images to be taken, have the image taken, and then through satellite to satellite communication, they'd be able to get that image down and drop it from hours to minutes.
That's terrific. I was going to do you have more thoughts on that, Karen? Go ahead. I was going to.
Yeah, just really quickly, I was just going to add, studying different environmental programs and initiatives, a best practice is timely push-based and exception-based alerts directed to relevant parties, whether they're citizens, regulators, various commercial stakeholders. That's going to be key as we move forward with some of these different constellations, monitoring forests, fisheries, coastlines, whatever, is push-based or exception-based alerts getting to the stakeholders on the ground to take action. And so latency, it may not need to be real time or even near real time. It just needs to get there in a timely manner.
Thank you, Karen. And I did want to loop back to you because we've just heard from Conor and Mark a number of the different remote sensing applications. And I was hoping you might share with us some thoughts on how these various applications can complement and validate each other for purposes of climate change. I can't hear you right now, Karen.
Oops, I think I was put on mute there by, okay, I think I'm off now.
We got you.
Okay, great. So we're living in the age of increased transparency at this point. And I think what we're going to start to see is greater coordination between local stakeholders, regional and national stakeholders. I have a slide that's relevant to this. Jennifer, if you could put this up on the screen here, that kind of the second slide, it's the other one. There we go. So this is something I think is important to think about. So as we look across the spatial scale here, we see that you have stakeholders that might be at the on-site facility level, and they often use fence line or ground monitoring. Sometimes they're inviting in, crowdsourced data, maybe someone with an iPhone filming illegal forestry or fishing or something. And then you have the regional networks that come into play, ground and air networks, state-run networks of air sensors, for instance, and planes that periodically fly over pipelines or oil and gas properties or landfills. And then you have the satellite coverage. For the age of increased transparency, we'd really like to see all these things integrated together in a way that increases trust if you have satellite data and you have crowdsourced data that validates it, I think you're going to see greater trust and action occur. And this will also encourage greater coordination across communities, environmental regulators, and it will also support these multilateral agreements and treaties that we want to get to, that we're going to be talking about in a minute. So I think that's going to be very important as we move forward with a variety of constellations.
Terrific. Mark, I wanted to ask you, when we started planning this conference, it was right around Earth Day, April 22nd, and so it seemed like a timelier question at that point. But were there any notable announcements relating to climate change and the role of satellites coming out of Earth Day this year?
Yeah, I mean, we had a very exciting announcement. I'll go ahead and take a swing at this on the T-ball stand. So we had a great announcement with CarbonMapper. So CarbonMapper is this public-private partnership that combines Planet with a spectrograph, an instrument from JPL, which is a NASA center in Southern California, with the state of California, with Bloomberg Philanthropies. So you really have the four corners all coming together. And what we're designing and will launch in the coming years. Launch will be in a year and a half. Will be a constellation of satellites that can detect point source methane emissions, and this is a huge deal. Point source methane detections is always prioritized as a data source that is needed in order to help address and identify where these emissions are coming from. It's a strong greenhouse gas that we need to regulate. And for energy companies, it represents, if they have methane leaks that they don't know about, they can capture that and sell that. And so it helps them make their business case. Mm-hmm. And then for regulators, it helps them understand where the emissions are coming from so that they can enforce the regulations. And so we're very excited with this partnership. We also think it's a great example of how we're all in this together. And it's not just about governments doing something. It's about governments coming together with states, coming together with companies and communities to bring these data sets, to make these data sets can become public goods, to make them publicly available aspects of them, and then to also enable a commercial market so that we can actually start to address this climate crisis, which affects us all. So it's Planet's rolling up its sleeves and partnering in this public-private partnership, and we are very excited to see this CarbonMapper get underway.
That is exciting. And you've talked about governments coming together, which ties in nicely to the next question I wanted to ask you about, particularly the U.S. administration and our government's role here. One of the first things that we saw President Biden do when he took office was to re-sign the Paris Agreement. And then at a more recent virtual conference in April, President Biden announced a new plan that's going to cut America's greenhouse emissions in half from where they were in 2005 over the next 10 years. Karen, would you talk a little bit more about the role of the U.S. government in climate change and what you're seeing?
Yes. So I think the U.S. must be in the position to lead here. We have an opportunity to clean up our own oil and gas industry significantly using CarbonMapper and other types of satellite industry. But some skeptics may look at this and go, what's new? Way back in the 1990s, we had the Kyoto Accord. And you may remember President H.W. Bush number 1, he passed the Clean Air Act amendments, which was really quite forward-leaning, but he would not sign the Kyoto Accord. And he did not sign it. He was reticent to sign it and decided not to, due to the inability to measure and monitor all signatory countries to the Kyoto Accord. And his concern was that the US would be held to a higher standard, which would allow other countries to free ride on the efforts. And the US would, be more strictly regulated than other countries. Well, since then, things have changed. Technology is out there, such as different types of methane sensing satellites and airborne sensors as well, that are allowing us to see greenhouse gases from space and air. The world is more transparent now, and it is now time to move forward with something like this agreement here. So I think we have to think about best available technology, and satellites should be part of that. EPA regulates according to what is best available technology, and I'd like to see EPA consider satellites on a more regular basis. I think that will go a long way, not only to complying with these multilateral agreements, but also help us on the state and local level as well.
And Mark, is that consistent with what you're seeing? Are you seeing that the administration is taking the right focus on the role of satellites that then they can play in climate change?
Yeah, I would say this administration, from the early days of the campaign to the transition to the executive orders signed in January 27th, through to the Earth Day pledges that came out just a couple weeks ago, this administration has been signaling consistently that addressing the climate challenge is going to be one of their priorities, and this is excellent. There's a number of the bars that, in order to address this challenge, where, as Karen mentioned, can be addressed, or at least partially addressed, through space and through observatories in space. And so, like Karen said, it would behoove us to develop plans as a federal government, both congressionally as well as from the administration, to find ways to better leverage this revolution that's happened in the last 5 years in the commercial remote sensing field. Because frankly, this capability did not exist in the commercial field the way that is propagated now just a decade ago, and really just half a decade ago. So for the government to acknowledge that this paradigm has shifted and that now there are these new tools available in order to meet their aggressive climate goals, I think would really go a long way. And so just a couple of the goals that they've laid out, that just to highlight some of the uses of satellite imagery: the 30 by 30 program, which is about biodiversity, protecting 30% of the planet by 2030. This is a clear-cut case of how satellite imagery, the daily imagery and mosaic imagery from a variety of different phenomenologies and sources, can help ensure the protection and the enforcement of the protection of these biodiverse rich areas. Coal power plant emissions, programs such as a carbon tracker, which can actually estimate the emissions of coal power plants and other power plants around the world. This can help, as Karen mentioned, bring a level of transparency across borders and into the public eye of how governments and communities are meeting their pledges and obligations. Tracking extreme weather is a priority as we're talking about mitigating the effects of climate change and helping those communities which before had depended on ground-based data and people on the ground and aerial, which sometimes is hard to do when you're in the middle of a hurricane. But a variety of satellite data sets can go a long way, not only to react to the disaster as it's happening, but also to monitor recovery and infrastructure after the fact. And then, of course, to rewind time with the imagery and understand how the disaster came about and how we can plan for and mitigate the disaster happening in the future. Climate research is an area that obviously satellite data through NASA's Earth Science Division, as well as Landsat, which is kind of a NASA USGS joint, as well as NOAA satellites with their weather monitoring, and Sentinel coming out of Europe. Obviously, there's a lot that can be done on the research side, but better leveraging all of this commercial data now and finding ways that this data complements and supplements this research will go a long way. So we're very excited by the energy in this administration and in this Congress about addressing a climate crisis, about environmental justice. And we think that space and remote sensing in particular, but space in general, has an important role to play here. And we are biting at the bit and engaging at all levels with the White House and with Congress to find ways that we can be better leveraged and quickly leveraged so that we can grow upon past successes and really get this data out to the communities and to the individuals so that they can make better decisions that will help curb this climate crisis.
And Karen, so now we've heard about the available data. We've heard about the government support for the data. Are we getting to action? You know, are we being accountable? Are we using the data to address the challenges of climate change?
I'm on mute again. We are definitely getting there. It takes a while to incorporate, you know, these cradle to grave kind of observation and exception-based alerts getting to the regulators, but we are getting there. I want to say I have been very encouraged by the oil industry itself. They have really changed their message, and they Shell and British Petroleum, BP, actually left one of their trade associations due to its opposition to the Paris Treaty. So we're starting to see these large oil companies come along, and that's my background, by the way. I have many years of experience as an exploration geologist, and methane is a huge, huge target. It's a very, very potent greenhouse gas, and during the first 20 years, it's 82 times as potent as CO2. So, you know, knocking it out of the atmosphere right off the bat will go a long way. So I'm encouraged. It is a huge existential challenge, but it is up to the EPA and our regulators to recognize, sorry, I have to repeat this, but it's so important, best available technology. They need to be fully aware of these new commercial systems coming online that can really play a very strong role in increased transparency. So I'm hoping that we'll see greater engagement from the satellite industry with regulators.
This has been a terrific conversation. We're running low on time. So if you have questions that you want to ask, please make sure you ask them now. I've got a couple more, and we may even run a minute or two over. But I did, something that recently came to my attention were these new ESG reports. The environmental social governance criteria. These are reports that companies are putting out in order to get investors interested in them. And they're trying to develop a green report card. Conor, maybe you or Mark,
yeah, sure.
Conor, do you have thoughts on is this going to increase the demand for satellite data and how we can use it? So they can
I think what we've seen overall is the incorporation of ESG in operational demand is absolutely rising. And it's not just essential that government adapt the best data available, but also industry to help establish those win-wins. You know, how do you totally change your business and reduce your emissions without having a dramatic impact on your bottom line or the economy? And so we focus on efforts like optimizing shipping routes, you know, so it's not just measuring data and change through space, but actually collecting data that drives action, and not just from governments, but from businesses as well. So if they can find, you know, open ocean weather is traditionally not optimized, and so our weather collected in those remote areas can really help drive insight. And also with different sort of route optimization algorithms and all this data processing that's now at our fingertips in the cloud, putting those tools in the hands of our customers in remote environments can be extremely impactful. So we've seen that. Certainly it allows a lot of analytics to be performed forward-leaning, and it's the same in the aviation industry and other industries as well. They're being tasked by their own governments, US or international, to slash their emissions to meet these ambitious goals we highlighted today. I think it's very important. And yes, I think we will see this discussed more and more.
Mm-hmm. Mark, and what do you see for the future? You know, what's coming? How can we improve the satellite data collection efforts, the distribution, action on it?
Sure, certainly. Just one thought on an easy way to think about the last question with the ESGs is you can't manage what you can't measure. And satellite data, whether it's from Spire or Planet or the dozen other remote sensing companies and different phenomenologies domestically in our country and internationally, they're providing data that allows governments and businesses to measure emissions, measure impacts, measure supply chains, et cetera. And so now that nature is on the balance sheet, that we're now that is now a variable that businesses are considering. It means that space will be on the balance sheet because you can't see the ESGs without us. We're the global reach to see the world every day, to hold yourself accountable and also to help improve your business, right? Because it goes a long way. So in terms of the future, there's a lot of really exciting things in our field. So over the last 5 years, we've seen this emergence of agile aerospace in the remote sensing field, right? So 10 years ago, we saw it in rockets and now we're still seeing all these new rocket companies coming online with SpaceX and Virgin, and Electron, et cetera. Now we're seeing that in satellite remote sensing as well. And so the market is getting flooded with all of this amazing and diverse data. So it's 25 terabytes a day just from Planet. So add up Planet's data a day, add up Spire's data, add up everyone else's data. I mean, we're dealing with an overwhelming amount of data. So where the future is going is how do we fuse that data together? How do we make it easy and actionable for the users to not just drown to death in this enormous amount of data, but actually pull out actionable, relevant pieces of the data that can then direct how they respond or how they make decisions in a very timely way. So this idea of data fusion, where we bring together different data sets so that they all operate together, this idea of improving analytics, which is an area that Planet is investing in, as are other companies, is how do you pull out those nuggets from the data set that are interesting to the customers in a timely way. And then how do these data sets, how do they work in tandem and complement the national assets? How do they work in tandem with Landsat, and how do they work in tandem with Sentinel? And as the government designs future systems like Landsat Next, how can those systems be designed in a way that commercial data is fully leveraged so that enables an even more seamless utilization between the two? So that's where the future is going, is automatic change detection, data fusion across different phenomenologies and different data sets, and future civil systems leveraging this commercial capability and then building on top of it so that you have this seamless interaction across the systems. And of course, getting that data out there as quickly as possible.
So maybe some concluding remarks, maybe from Karen and then Conor. Mark, I'm going to take your thoughts on the future as your concluding remarks here. But Karen and Conor, any final words that you'd want to share?
Well, I'll start with environmental social governance, ESG criteria, which is the way investors evaluate companies that they might want to invest in. And ultimately, ESG scorecards tell you who's a good steward of nature and of the environment. It's a green report card. Some are skeptical about it. I believe it's the way to go. And satellites will have a strong role to play up in the sky, looking at who are the good actors, who are the bad actors. Also, as a former petroleum industry exploration geologist, I can tell you that the natural gas industry could play a really important role as a bridge fuel by replacing coal-fired power. However, you need to understand this type of fuel source from cradle to grave, and there are bad actors spewing enormous methane plumes, and I think it's dollars going into the atmosphere, but there's a lack of oversight now. And I think ESG criteria, working in combination with satellites, airborne imagery, and ground-based sensing, will play an enormous role here in cleaning up the planet.
Thanks, Karen. And I'll just say that I think we all carry our own biases, but we recognize that satellites are the ultimate vantage point. And both public and private investment and collaboration is absolutely essential so we can lean in and take on some of those projects Mark talked about. There's no one data set that can drive all the action required. But how do we fuse these data or even assimilate these data and create predictive models with so many new analytical tools at our fingertips? And a large element of that is outreach. And we don't have time to cover this all today, but making sure the researchers know what data is out there, formats of the data sets. And like Planet, we've had success working with NASA and the different agencies on that effort. But that needs to be a continued initiative as we are constantly enhancing the types of data we collect. There's nothing worse than data going there unanalyzed or not being fully utilized. So Spire looks forward to participating in this. We're leaning in and we look forward and thank everyone for the time today. It's really been a pleasure. We could probably go all day here, couldn't we?
We probably could, but thank you, Karen, Mark, and Connor, and especially Tom and everybody at SIA who worked so hard to make this a successful first webinar. I think it was, so thank you.
Jen, one last plug I'd like to say is just for everyone's awareness, on Tuesday, there'll actually be a House Science Committee hearing on NASA Earth science and climate change activities and the current roles and future opportunities. So it's another opportunity for people to tune in, and it really shows how Congress is recognizing that that space has an important role to play, and I think it'll be a great hearing. So Tuesday at 11 a.m.
Well, thank you. I'm glad you mentioned that. I should have given you the last words. Tom?
Great, thank you. Well, Jen, Connor, Mark, and Karen, this was a fascinating discussion, and Jen, you're right, this was a great kickoff to our webinar series. I'd also like to thank all of our attendees. We'd love any feedback that you have, suggestions for next webinar topics. We'd love to get your input, and I know we only covered a portion of what we could today, so this may very well be a part 2 on our future agenda. Our June webinar, the Resiliency of Networks, will be held on Thursday, June 17th at 11 a.m. Eastern Daylight Time, and we hope you can join us. On behalf of SIA, I want to thank you all again for joining us today. We look forward to seeing you at future webinars, and definitely look forward to seeing you in person at future events in the very near future. So with that, thank you, everybody. Stay safe.